Hello, I welcome you all in this presentation related with the subject materials processing, fundamentals and practical. And we are talking about the powder metallurgy. In this particular presentation, I will be focusing on the different steps which are used for manufacturing the products using powder metallurgy approach. So, as far as content is concerned, like that for making the products using powder metallurgy approach, we need powders of constituent materials. Okay. So, these the powders of the specific constituent materials of which we want to make a product, we try to identify the proportions. This is the first thing, like what is the percentage of A, percentage of B or percentage of C type of constituents. So, this is about the proportioning of the type of constituents. Okay. Proportioning we also do for the size of constituents. Okay. Like the 100 grit size, 50 grit size or 20 grit size, the proportions of the different grit size, say 20 grit size 40%, then 30% and 30%. So, the powders of the different sizes are also identified with regard to their proportions. Okay. So, these are the two types of the two types of the proportioning which is done to develop the product of the desired composition as well as with the desired soundness. Okay. So, this kind of the proportioning is important for making the product using powder metallurgy approach. Once we have identified the different constituents A, B, C and their proportions in terms of the type of constituents as well as sizes, it is important to do the proper mixing so that there is uniformity of composition, structure and properties. Okay. So, the blending and mixing of the different constituent powders is important. Suitable blenders and mixers are used for this purpose to ensure uniformity of the composition, so that the products using powder metallurgy is obtained which are of the largely uniform structure and properties. This is the first you can say the major step after the blending and mixing of the powders. These powders are put in the mold cavity. Okay. So, this we can say as a die of the suitable shape as per the shape of the product which is desired. So, these mixed powders will be put in the die. Okay. And after that, so when it is put in and it is filled in, there will be under the gravity it will be filled in. So, there will be lot of pores and voids between the powder particles. So, obviously, there will not be any kind of the binding or the bonding between the powder particles, they will be just loosely connected with each other. In order to impart the shape through these powders are pressurized. Okay. So, when these are pressurized, powder particles tend to get deformed. Okay. When they deform, they form the cold bond followed by the plastic deformation. So, the application of pressure will be causing the plastic deformation, bringing in the powders in metal in contact with each other, and that in turn will also facilitate the development of cold bonds. Okay. So, when this cold bond is developed, we are able to impart some strength to the component that will be produced after the compaction. So, we will be getting the powders which are loosely connected with each other, weakly connected with each other. So, the product obtained this way will have the less strength, but it will have the shape which is desired. Okay. So, this kind of the partially processed component is called green briquette, a green component or briquette. Okay. So, this green component, a green compact has very low strength because the bonding between the powder particle is primarily due to the plastic deformation coupled with a mechanical interlocking and cold bonding. So, in order to impart the desired strength it is important that there is a metallurgical bond between the powder particles. So, in order to establish the metallurgical bond between the powder particles, sintering is crucial. Okay. So, this sintering, depending upon the kind of the material, it can be done in 0.5 to say 0.8 times of its melting temperature. Okay. Very high temperature is used, so that the diffusion and interaction between the powder particles can take place for developing the metallurgical bond. And once this is developed, the desired porosity free component is obtained with the desired mechanical properties. So, sintering is basically the high temperature process, which is usually done in controlled environment. Why? Because if sintering is done, there are powder particles which are loosely connected with each other through the mechanical interlocking and cold bonding, and if they are heated at a high temperature in normal ambient condition, then some kind of the oxide layer or reaction products at the surfaces can form, and once these are formed, then diffusion across the powder particles will be restricted, and that will adversely affect the metallurgical bond formation. Therefore, it is important that the heating for the sintering is done in controlled environment, which can be reducing environment or it can be vacuum as per the need. So that when the green briquette is heated to the higher temperature, no impurities or oxide layers are formed between the powder particles which are being sintered to develop the desired mechanical properties. There are many secondary processing. Once the desired shape and structure and properties is attained, it is very much possible that this may not be having the all set of the characteristics which are desired in the product manufactured through the powder metallurgy route. So, if the product is lacking in certain aspects, then those are compensated through the secondary processing. Okay. So, what is that? Impregnation is one, like if there are a lot of pores, then these pores are filled using the suitable resins. Okay. So, these resins are filled in under the gas pressure. Then sizing, if we need much more and higher dimensional accuracy, then machining can be performed, which will help to remove the unwanted extra material and attain the desired dimensional accuracy and surface finish. Sometimes the products which are attained through the powder metallurgy may not be having the desired characteristics in terms of the hardness, in terms of the wear resistance. So, sometimes these are coated with the further harder material at the surface, so that they can perform for long, and the tool bits are the typical examples of the products which are made through powder metallurgy, followed by coating. So, we can do the coating of titanium carbide, tantalum carbide, or like say the alumina like this. So, depending upon the titanium nitride. So, the various types of the coatings are developed using the PVD or CVD kind of the methods to develop the surfaces of the higher hardness and higher wear resistance. The sizing is the another method where because the whatever product is obtained through the powder metallurgy, that is usually near that shape. It may not be as per the requirement of the size and shape. So, what we do, we take the die of the desired size. In that one, the product is placed, okay, and then this is pressurized. So, when it is pressurized, due to the plastic deformation of the material in form of the component, that helps in attaining the desired size and shape. Okay. Then we have the infiltration. Infiltration is about if there are pores in the powder metallurgy product, then these are filled in by the molten metal. Okay. So, that these pores are filled in by during the infiltration. So, the porosity is eliminated through this approach. The heat treatment can be done in order to realize the desired microstructure and mechanical properties. Okay, so that was about like the overview of the content and the significance of the different steps which are performed. We will try to see these things in detail. Say approach of the powder metallurgy is what? It uses the powders for making the product, which are usually made of the variety the different incompatible combinations, say metal with the non-metals or metals and the material combinations which are not metallurgically compatible with each other. Like say there is a, like we can use tungsten carbide in matrix of the cobalt, or nickel we can use graphite in matrix of the copper. So we try to make the products using such kind of the combinations which are not otherwise metallurgically compatible with each other. Such kind of the products cannot be made using the other approaches, say casting, forming or welding, because of the metallurgical incompatibility or difficulty in melting, machining or forming. So, we use a powder metallurgy based approach. So, as I said, proportioning and mixing is one thing. So, we do the proportioning for the different types of the components in the desired proportions. So, that the one proportioning is proportion identifying the proportion of the different constituents, then size proportioning. Then the powders of the each type of constituent in different sizes are identified and they are mixed, and then size range. So, once we do the proportioning of sizes, then we will be able to have the desired size range. When we have desired size range, it helps in reducing the porosity, it increases the sintering and compaction stages because of the reduced gap. It increases the apparent density. Okay. So, these things help in developing the powder metallurgy products easily in shorter time because of the improved diffusion, reduced porosity. So, that in turn will help in developing the desired product. So, the different types of the constituents in the powder form and the sizes of their powders, different the powders in the different sizes is for having the desired size range. All constituents in powder form must be blended and mixed using suitable mixer and blender for uniformity of composition, microstructure and mechanical properties. Okay, like this. Then another stage is compaction. Okay. So, in compaction, say this is one powder, this is another powder particle, this is another powder, like this. So, when we apply pressure using the suitable die, okay, what happens die and press arrangement, what happens like these powder particles need to be deformed. Okay. So, when these will deform, they will get flattened, they will come in contact with each other like this. So, when they get flattened, they will be coming in contact with each other due to this plastic deformation. Okay. Once the powder particles in due to the plastic deformation have come in contact with each other, it will be resulting in the mechanical interlocking. Okay. And when they are perfect in material contact with each other, it will help in development of the cold bonds. Okay. These two things when happen, the powder particles try to hold each other, but with weak strength or with the weak bonding. Okay. But there are few things to be kept in mind, like it is difficult to deform the powder particles, especially the spherical shape powder particles, to facilitate the mechanical interlocking, as compared to the case when we have the irregular shape powder particles. If we are having already irregular shape particles, then the mechanical interlocking and bonding between them will be far better. So, this is one aspect. If we have the powder particles of larger size, it is easier to deform as compared to the small size particles. So, material aspect is one, like soft materials will certainly need the lesser pressure to cause the plastic deformation of the powder particles and facilitate the mechanical interlocking and cold bonding. But even for the low strength materials, if we see larger powder particles are easier to deform as compared to the finer particles. That is why the kind of pressure which is used for compaction to facilitate the deformation of powder particle is much higher than their flow stress or yield stress of that particular material, and this usually varies from say 600 to 1600 MPa. Okay. So, the pressure which is required to facilitate the deformation of the powder particles and attain some shape of the product as per the shape of the die in form of green compact, which is of the low strength semi processed product, the pressure requirement is very high, and this in turn limits the size of the component that can be processed through the powder metallurgy route. We will try to see these details in these things in more detail. Like in compaction, powder mixture of constituent is is placed or poured into the die cavity, then powder mixture in the die cavity is pressurized to very high pressure, okay, say 600 to 1500 MPa as per the material, using the suitable press to facilitate the powder particle deformation, that in turn will help in mechanical interlocking due to the plastic deformation of the powder particles, okay, at room temperature. So, important part here, compaction is done at room temperature. So, powder particles must be deformed at a room temperature. So, powder particles have been, say this is the die, this is the punch, and the powder particles have been filled in this die. Okay. Then it is pressurized. So, when it is pressurized, the porosity between the powder particles will be reduced. The voids and pores which are there between the powder particles, that will be reduced, okay, and it will be forming the briquette or the green compact. Then this is taken out, okay. So, powder particles need to be deformed so that the mechanical interlocking can happen by the plastic deformation at room temperature. Deformation of fine powder particles needs much higher pressure than their yield strength, because it is not easy to deform small size fine particles as compared to the bulk ones. Pressurization and deformation of powder particles result in the mechanical interlocking between them, leading to the development of the relatively weak bond between the powder particles. Thereafter, the powder particle with the help of suitable ejector is taken out. As a result, the low strength product that is obtained in the desired shape is called is obtained after the compaction. The product obtained, semi processed product which is obtained after the compaction, is of low strength. Weak product made after the compaction is called briquette or green compact. To impart the desired strength to the green compact through the metallurgical bonding, sintering is extremely important. That is the next step. So, requirement of high pressure for compaction limits the size of the product that can be manufactured by the powder metallurgy, and ease of compaction is called compactability. Compactability, a simple measure of compactability is the pressure required to achieve given level of density in green briquette. So, even if there is a the briquette which is formed, there will be lot of porosity. Say porosity after the compaction is say 20%. Okay. Then how much pressure is required for making the product or the green green compact or briquette with the 20% porosity? That pressure becomes the measure of the compactability. Lower is the pressure to attain the desired level of the porosity or desired level of the density in green compact, higher will be the compactability. So, lower pressure requirement means higher compactability of the material. During the compaction, pores and intermetallic particle, the gap between the interparticle gaps are reduced, which in turn increases the density of the green briquette. This happens due to the collapse of the pores and voids which are there between the powder particles. Compactability also depends on the multiple other factors such as the material hardness, hardness of the constituent materials, their size, shape, size range, surface roughness, interparticle pores, etc., as per the method of manufacturing. Okay. So, spherical shape particles of the large size, they will have better compactability as compared to the fine powder particles. This is one. The second one is what? Where the shape is there. So, irregular shape powder particles will be offering the greater compactability as compared to the spherical size. So, soft, small size, round particles of the smooth surface with the wide range of the powder particles offer the higher compactability as compared to the hard, large size, regular shape and other rough powder particles will be offering the lesser compactability. Powders produced by atomization methods are smooth, spherical as compared to those obtained through the reduction of oxides and the grinding followed by grading route, which are irregular and the rough ones. So, here the next step is sintering. In sintering, what we expect, like whatever the weak bond is there between the two powder particles. So, just after the compaction there will be the mechanical interlocking mainly or cold bonding. Okay. So, this results in the weak bond between them, and therefore, the strength of the briquette or the green compact that is obtained is very less. So, what we want, at the interface, the metallurgical bond is established. Okay. To establish this metallurgical bond, it is necessary that diffusion across the constituents and diffusion across the interface between the powder particles take place. And to facilitate that, there are two important aspects. One is the temperature and another is the time. Certainly, to have the clean interface and direct material to material contact between the constituent particles, environment also plays an important role. So, we try to have the reducing environment or vacuum environment for this purpose. When high temperature is maintained for long time, then diffusion across the interface facilitates the metallurgical bond development. Okay. So, now we will see the things in greater detail. The mechanical interlocking due to the plastic deformation of the powder particles imparts the strength to the green compact or briquette during the compaction, but this is not enough for many engineering applications. Therefore, desired strength in the component is made through the powder metallurgy route, which is obtained by the development of metallurgical bond at the during the sintering stage. Sintering involves heating of the green compact between the 0.6 to 0.75 times of the melting temperature in Kelvin with or without pressure for long enough, so that the diffusion across the powder particles can take place. This in turn facilitates the interparticle metallurgical bonding, and at the same time it also facilitates the reduction of the porosity and voids. So, this is what we can see. Initially, say these are three powder particles in contact with each other obtained after the compact. So, the diffusion across the interfaces will be taking place, but still there will be porosity or gap between them. So, it is required that the diffusion continues for longer time, so that this kind of the void or the gap is eliminated. Okay. So, what is the process like in the control chamber? Like say the components are placed, then they are initially preheated, so that all impurities, moisture, if there is anything, that will be eliminated. Then here the main sintering will be happening to facilitate the diffusion across the interface of the powder particles. Thereafter cooling will be happening. Okay. So, during this sintering process in this chamber, the diffusion across the interface will be facilitating the development of the metallurgical bond with the reduction in porosity. So, atomic diffusion across the powder particle interfaces, where the metal to metal contact is established, interface of the green compact at a high temperature as a function of time develops the metallurgical bond without any distinct interfaces. Okay. A sintering of the component for very long can help in reducing the interparticle voids, say 90 to 95% through the volumetric diffusion, but it may not be very justified financially or economically to eliminate all the voids. So, even if the 5% voids are left, that should be fine for realizing the desired performance of the product. However, it may not be feasible to eliminate all the voids to realize the desired strength, as it would be extremely time consuming. without much gain in terms of the strengths. That is what we see here. These are the powder particles in the beginning. Okay, the contact here is very localized here and there. Okay, when so this is what is obtained just after the compact. So in the initial stages, the some kind of the metallurgical bond will be established, and that thereafter the diffusion across the interfaces will continue to reduce the white percentage. Okay, and this white percentage will be reduced significantly with the progression of the sintering. Okay, so here there what we have seen that whenever the products are made through through this powder metallurgy approach, the products are obtained may not be suitable directly for the applications, say in terms of the size, specific size requirement, like in terms of the tolerance, the allowed tolerance. Okay, this is one. The second, it may still be having the porosity beyond the acceptable limit, or it is also possible like the surface characteristics are not really suitable for the given application, the sizes are not proper, or the microstructure which is realized is not also suitable for the given application. So, therefore, what is done, post sintering treatments are applied to obtain desired surface finish, dimensional accuracy, densification and sealing of the pores, and that is done, say machining is done using like say grinding or super finishing methods that can be used for realizing the desired dimensional accuracy or surface finish. Okay. So, this is one. Impregnation, like the filling of the oils or resins. Okay. And in infiltration, where the filling of the molten metal is done to fill the gaps that is there due to the pores. Then coating using the methods like PVD or CVD kind of approaches are used for development of the coatings over the surface of the products obtained through the powder metallurgy. Okay. Sizing is involves like compaction of the product made after the sintering in the die of the desired size, so that the plastic deformation helps in realizing the better control and accuracy in terms of the dimensions of the product. Then the heat treatment as per the functional requirement of the end product can be done, which may be like to develop the desired microstructure and so the mechanical properties in the product after making it through the powder metallurgy route. These secondary processing steps help in improving the performance and characteristics of the product made through the powder metallurgy. Just for example, say if a product is having like these pores, so these pores can be filled in with the help of suitable resins in case of the impregnation secondary step for making the product. So, as I said, this the powder metallurgy route is very commonly used for making the products of the composite materials like the nickel or cobalt matrix coupled with the tungsten carbide, titanium carbide, tungsten nitride, etc. So, these are extremely hard and brittle when these are the embedded or fixed in the matrix of soft and tough matrix of the nickel or cobalt. This helps in development of the tool bits. Tool bits allow the machining at a relatively much higher speed as compared to that of the simple high speed steel cutting tools. So, now I will summarize this presentation. In this presentation, basically I have talked about the different steps which are used in powder metallurgy method, like the blending and mixing, compaction and sintering, and thereafter secondary processing is done for improving the performance of product made through the powder metallurgy route. Thank you for your attention.